summary of that on page 34. Quite important. Okay, so please, does it capture the whole board? It's fine. We'll just find a video editor and we'll see. I wonder how long it can go. It should go longer, right? Hours and hours. Okay. Inequalities, we're looking at quadratic inequalities. Now here's the thing now that I want you to understand. Inequalities, this is just quadratic inequalities, which is based on the quadratic function. Y equals to f of x, which equals to a x squared plus bx plus c. We're going to do other topics, other functions like logs, logarithms. We're going to have a logarithmic function. We're going to have logarithmic equations. We're going to have logarithmic inequalities, log inequalities. We're going to do absolute value graphs or functions. We're going to have
this function of a log function is exponential function.
So the only thing I'm saying is this is not the last time we're dealing with inequalities. This was just inequality based on quadratic functions. All other functions that we're going to deal with, we're going to deal with their inequalities as well. Okay? If you have a look at your table of contents, you go, for example, to, let's see, log equations, log identities, I don't see it. I think it's further. Look at chapter 9. Are you there? 9.4. Solving exponential equations. And guess what? Inequalities. If you look at, there is something about logarithmic inequalities also. Solving 9.4, solving exponential inequalities using logarithms. The moment you are using logs there, something happens. Like, for example, if the basis of fraction, the inequality changes direction. We'll get to that.
Basis of fraction.
Yeah. But please, when we get to differentiation, and I want you to have a look at, not the one, let's take the one in theme 1. You see, differentiation. There is increasing, decreasing rates of change. There should be, you should be able to sketch the functions. Sketching. Just go to page 255 in your book. I just want you to see that you are going to see some quadratic functions that are probably sketched there, even cubic functions for that matter. Can you see 256? Can you see the graphs are coming in? Not as much as the ones in the old high level, because we have done sketching, but for cubic functions, look at page 272, page 274, 275. Can you see that they are using sketches in order to solve questions that deal with the log functions or whatever you are dealing with the quadratic function. So what we have learned in chapter 1 carries through when we get to those things, and you should not forget. Okay. Then also, I'm at page 34. We have been doing this morning, we have been looking at identities, and the way that we solve identities is we just equate the coefficients. You also see that it's not really that technical. The only type of questions that we like to give is like the first one that I took from the specimen text. The one that I also gave you something similar in the test, the fraction ones. Okay, you should be able to see that. Well, if it's an identity, then I can just multiply out 1 so that I can equate the coefficients. When you are trying to prove when something is like what we do in long division, when something is a factor, you can also use that. It's just longer, sometimes unnecessary. Okay, this brings me to something I want you to quickly have a look at. So I'm starting with determine the equation of a cubic graph. I want you to look at the formula that you are given. They are giving you a formula. Is it the equation? No. Okay. Let's do a quick revision of a quadratic, which we know as what? Parabola.
Parabolic.
So have a look at page, because I wanted to do some comparison. I usually page 24. Look at page 24. It's given to you as y equals to a, something in brown there. Next. X minus x sub 1 or a. Okay, then x minus x sub 2. Now we actually like to use Greek letters. So if you're given a polynomial x, capital letter P, right? Then it's going to be x minus alpha, x minus beta, and then x minus lambda. Looks like a y. Looks like a y. Not lambda, but gamma. Alpha, beta, gamma. These are just the y-intercepts. This is the cubic one. Let me just stop there for the quadratic. The same application we are going to use to determine. Remember here we have two ways of finding the formula. If you are given the turning point, when there is one method also where if you are given the turning point
TP
and other
y equals
point, right? Then you use your vertex form.
yes, gracias.
Is it not so? And from there you can rewrite it there. Then there's also another method where if you are given your y-intercepts in another point, then you are using this method.
Yes.
So this will apply to method B that I'm referring to. Here they give you the x-intercept. Where does the parabola cut the x-axis? Okay? But there are different types of parabola also. You find parabola there. Cut the x-axis at two places, distinct routes. Then you also find those that just touch at a certain point. So if this was the point 1, or let's say this is the point 4 and this is the point 1, then the root here, alpha equals to 1, or beta equals to 4. Then, is it not so? Those will be the roots. If this here is minus 3, so the way you are going to put this now, obviously you are going to put them back there. But you must realize something. There is always minuses in our general formula. You follow?
Yes.
If the x is a negative value, it becomes a positive and so on. But the formula always have a negative, always have a negative, and it will be the same when we look at the cubic function. Always minuses. In this particular case, this is a repeated root. So a repeated root will be something like y equals to a in bracket. If I have to write this one down, it will be x minus, let's say that 3, but it will be squared. It will be that is squared. Before, okay? So it touches there. So here I can use maybe, let me use this one. So we have such things when we have this type of functions that touches. Those ones, they cut the x-axis in two distinct groups.
Yes.
You also have functions that do not intersect. In this particular case, delta is less than equal to, less than 0. So the roots here are what? Imaginary roots. Yes? Yeah, yeah? I do not.
No, sir, it's not about that. You have to solve something out of reflection of the project.
You wanna? Okay, no problem. Yeah. So in this particular case here, right, there is no way for you let me ask you this question. Is there a way for you to write the formula using the method where, obviously there's no x-intercept, so this one is out of the way.
Yes.
But can we use this method? So if you are given the turning point, yeah, and you are given one other point,
Yeah.
but you can't be given the turning point as well as the turning point. The other point can also not just be the turning point. You understand what I'm saying? Right?
Yeah.
Because if this is like the way this one is now, it now looks like
Maybe the y
determinant now.
maybe the y
will
is-
be 0 here.
Maybe the
Okay.
way it is.
So it has to be the turning point, and maybe they give you. But now here, in this case, you can use that if the y-intercept
Yeah.
is not also the turning
Yeah.
value. You understand what I mean? For the y-axis. For the y-intercept. So yes, you can, but you need a little bit more information to such type. But what we were focusing on when we were dealing with this type was given your x-intercept, the roots, plus one other point. It could be the y-intercept, it could be another point. Or you are given the turning point with another point. And then you just substitute the value. Now, the difference between the equation of a quadratic or a parabola and the equation of the one that we are going to look at now, I'm going to cubic function, is cubic graphs have local maximum and local minimum. I'm just going to put it through. It means there is no highest point for the graph, but it turns. So you have like a turning point here, but you call it local maximum, and it's another local minimum. Can you see that? So it does. It's not like a parabola where you have the minimum. This is the lowest point of that. If I was to ask you, and we're going to do functions, I think that's the topic after chapter 2. When you do functions, you will have to sort of give the range of this graph. And the range will be whatever the lowest value here of y is. So if suppose y will be anything greater than or equal to whatever, say let's say that was negative 1. That is the lowest point. Then that is the function. If it's the other way around, then y will be less than negative 3. That's the highest point. So we can actually write it down like that. But this does not have the highest point. It also doesn't have the lowest point. So we just call them local maximum and local minimum. Also, a cubic function, which is normally a function like ax cubed plus bx squared plus cx plus d, where a, b, c, and d are obviously constants. If the value of a, which obviously a cannot equal to 0, because if a is equal to 0, it becomes a quadratic. You understand that? If the value of a is greater than 0, that means the value of a is like a number that is positive. Then when you sketch that graph, it's going to be like that. If the value of a so the arrow indicator goes on. The value of a is less than 0. That's how it will be when you sketch it. Then you also have instances where you have intercepts here. Can you see that? The same can apply here. So I want to talk about that stuff. So we're not going to find the minimum, the local minimum and the local maximum. Because in order for us to find the coordinates of where they turn, we need to apply differentiation. So it's not like the parabola. You understand? So the only thing that for this course, we need to find a polynomial such that your a value is obviously a. Then you have x minus alpha, x minus beta, and x minus lambda, or gamma. Which means if given 3 intersect, but this is not the only type. The general formula is their minuses. That is what I want to bring to your attention. Here the general formula is their minus, x minus alpha, x minus beta. Irrespective of what your root is. If the root is negative, obviously you punch it in there, it becomes positive. But the general formula must have minus. You understand that? So, you have 4 types of cubic graphs. So let's look at type 1. type 1. 4 types of cubic graphs. This could be type 1, where you have your x-intercepts at alpha, beta, and gamma. That means we have got 3. And then they will give you perhaps, what is it? Another point here. You understand that? So given a point, that is going to be your value of y and your value of x. You understand? Given a point, and then given the 3 scenarios where the graph cuts like the one that you, I think, the one in the text. You understand? But you also have, now remember it can also be negative, it doesn't matter. Right? You also have type 2. I'm just taking them differently here. You could have a graph okay? So suppose that's x, suppose that's y. What you are realizing here is just touching at a certain place. And here you have got b. So these are the types of the polynomial is a, then if x minus alpha all squared, you follow? Alright? And then obviously the other one will be x minus b. So it's like it's touching. Remember, it's similar like when you have something like this, it's touching. Like a repeater. You follow? Also remember, what I'm saying here is we're not going to look at the turning points there because we need to bring in more. Okay? Not so obvious. Then let's bring in a third type. A third type could be it only cuts the x-axis only at one place. This is the type where the polynomial is a equals to obviously x minus alpha, but here is ax squared plus bx plus c. And where this delta here is less than equal to 0. It's less than 0. That means you know that second part. Let me explain it in simple terms to you. A linear multiplied by a parabola by a quadratic. A linear times a quadratic gives you a cubic function. Is an answer.
Yeah.
So one is a factor, one cuts here, so there is a solution. But the other one, that one, does not cut. So that is where you have instances like the graph, your cubic graph only cuts at one place. It could also be from the negative point. Doesn't understand? So the other part, values of A and B and C exist, yes, but it only cuts the x-axis at one place. That's type 1. We're going to have to look at maybe an example of the sort. Type 4. That's 4. You can also be from the other side, by the way. Okay. This is like a wall. Think of something that you stretch like a, what do you call it, raking. What is a raking? Huh? What's Lasto. Something elastic, right? When you pull it, not too tight otherwise, right? But just do what you think of this function as you're pulling it. Now, you can't really determine the turning point. Do you see what I'm saying? So you can't physically say, oh, that's where the turning point, the local turning point is. It's like it sort of rests at that part. And what we are referring to, that point, we are saying it has a point of inflection. You see that? Yes, it still has one solution here. So this is the type P of x equals to x minus alpha all cubed. I hope you understand. There are examples where we have to look at x minus 3, x plus 3 all cubed. Remember when you multiply this out, it's x minus alpha, x minus alpha, x minus alpha. Okay? Which will give you this type principally. You follow? Right? But when you sketch it, when you draw it, it's going to have that point of inflection where it's not as obvious for you to see. You understand? Right. So these are the 4 types that exist, and you need to know how the function will look like before you just look at sketches.
Yeah.
We're just going to focus at giving you any one of this information, and then we want you to complete the equation. So you will leave the equation in this form. You don't have to go multiply out the equation. So that it's in this form. Does that make sense? So let's look at a few questions like that. Only a few questions. I was doing good there. Can you see the thing nicely? Because he was taking pictures normally. Okay. But it doesn't mean you should also not write down. Let's look at an example. So this is the last part of this talk. Okay. After this, we are going to go to topic, which is a revision of few things that you should remember, APs and GPs. I'm going to look for spicy questions. Okay. Right. Triangle 36 days. Find the equation of the cubic function whose graph cuts the x-axis. They have 3 places and then it cuts the point. That is nothing but the first type that I have indicated. Okay, so it's going to be x plus 2. Yes, x, because x minus 0 is just 0. Right? The other one will be x minus 3. I'm talking about the very first question. Triangle 36.
Oh, yeah.
Okay. So, what are the x-intercepts? What are the x-intercepts? The x-intercepts of 2, 0, and 3.
The origin.
And then they also give you a point. Negative 1, negative 4, am I right?
Yes.
So this is obviously
That one.
that extra point that we are going to have. Right, so it's that first type. So it's going to be y equals to a x minus negative 2, x minus 0, x minus 3. It's always minus. Okay? Right. X and y is replaced by negative 4 equals to a open bracket. Now we have got negative 1, yes? Plus 2. Negative 1 minus 0. I don't even know why I'm putting minus 0. Negative 1 minus 0. The idea is to find the value of a. Okay? Right. So here we're going to have a in bracket, we're going to have 1. Here. Here. Negative 4. Am I right? So negative is just going to be positive. So 4a equals to negative 4. Then a equals to negative 1. So therefore, the equation is y equals to negative x. You come back here. Plus 2. X. And then looks weird. Let me put the other one first. Then x plus 2. Then that equation is done. Okay.
Yes.
Doesn't make sense.
Just put it.
The value of a is one, yeah? Understand? Again, you can also take away that x. That goes
Which
with
means
it.
let's get the function goes.
Yeah. So it's going to be the one, it's going to look something like this. Okay. Because the value of a is what? Is
Less than
0. So we are going to ask you to sketch, not really because of returning, but we want you to determine the equation given this information. Now, when you look at the other one, it's exactly the same type of question. The only difference is now you're doing a sketch. So you must identify that third point. For example, there are 2 points, but 2a, there's the point 0, negative 8. But the experience has taught me. I should not always assume things.
It doesn't get this.
Yeah. Not always assume things. I'm just going to do one and then I'm going to go to the other ones. No?
0, negative.
So you have the graph there, and which side is it? This side. Negative 8 is here. Negative 1, obviously that's the origin is
Yes.
Then that is 2 and that is 4, right? Yes?
Yes, sir.
Y here, x here. So this is the point. This is the point here.
Zero.
The point 0, comma negative 8. You understand? So you use the same concept and just substitute. So it's going to be negative 8 equals to 8, then x
Zero
plus 1, right? Then x
plus
minus 2, then x minus 4. I hope you get it.
yeah. It's
Okay. I decided not to put the x there
Yeah.
so that you don't get confused. So let me just put y here.
That's zero.
Then it's going to be 8, then x obviously is what?
Zero.
So it's 1.
Yeah.
Negative 2. Negative 4. Negative, negative, that is 8a equals negative 8. Then a is obviously negative 1. So now you can continue write your equation. It's going to be y equals to minus, in bracket, you can say x plus 1, x minus 2, and x minus 4. Does everybody know how to go to x plus 1 here?
Negative. Plus plus a negative.
Remember, it's going to be, this comes from x minus negative 1, right?
From a negative.
Is it not so? Subtracting from a negative, instead of adding. There you go. There's something missing here. What?
One.
Good. There you go. So, no need to
It's
multiply.
the same.
That's all that we are looking
It's
for.
the same function. Just go down.
So the only difference you have now, at try now 37, which I think we can finish, is the other type that I was referring to. So, try now 37, it says, find the equation of the function which keyword here touches the x-axis at what? At 1. And then also it cuts the y-axis, I believe. Let's say cuts. No, it cuts the x-axis. Yeah, cuts the x-axis at, so it's another point now.
Yes.
What is it? Negative 2.
This is
And passes at what point?
4.
Through 4,54.
Type 2, sir. You can see.
That is like that type 2 that I was talking about.
Yeah.
So something is going to touch, right?
Yeah.
Yeah, so it touches at 1. So
Repeat
now here's the thing. You can't really start sketching. That's why I'm saying we're not doing the sketching now here. Alright?
Repeat it.
If I ask you to sketch it, then you just generally will have an idea. First, you need to know what is my value of A in order for me to say, well, is it something that will be, yeah, this is going to be a right. Like for example, because it touches, yeah, no, this is definitely not how I am looking at it, because negative 2 is here, and obviously 1 is here.
That's
okay. All right. So, is it going to be positive or does it touch? Remember, you can also have those that goes from here. Okay, how does it go? It touches, it cuts at negative 1, right? You know, it cuts at negative 2. So it can go, you must not be with me.
Just touch.
Wait, let's see. No?
Just touch under.
It touches under.
Yeah, under. Yeah.
So if it touches under, it goes the other direction, right?
Yeah.
You understand that?
Yeah.
It's still negative 2. This is still positive 1.
Now you need to find.
You follow? X still here, Y still here. So when I say sketch this information is not clear because you don't know the value of A.
Yeah.
In this case, it will be if A is greater than 0. In this case, if A is greater than 0. You understand? Does that make sense?
Yes.
Is this correct? Look. Example. 2 of them. Touching. Example A. A is negative 2. Right? Some function like this. I know it's funny looking. B, A was a positive number. It's something like that. Can you see that? Does that make sense?
Yes, sir.
So it's like, I don't know, top
Just
left,
A value.
to the right, bottom left, top right.
Oh,
Top
yeah.
left, bottom right. If you were looking at it. You know, maybe I put the arrow there.
Yeah.
But it can also be anywhere, right? Bottom left, top right. Starting here, I go up there.
Bottom right.
Positive.
Bottom
Greater
right.
than zero.
Top left.
Exactly. Well, you will determine when you draw it. But anyway, when I'm interested in sketching, I want to find the equation, determine the equation.
So we can only sketch the differentiation.
Yeah, if you really want to sketch it, then obviously you need to find the local number, but you can still draw some sort of sketch where you can just indicate the intercepts or the y-intercept if you are given stuff like that. You understand?
Mm-hmm.
Okay, so given this information, we now know it is a function basically that is going to be, it touches, so x minus alpha squared, and then the other one is going to be x minus beta. You understand?
Beta.
Obviously, don't forget your a. Okay, let me just make this p. Don't know. Right, so y equals to a. What did they say? At 1?
Mm-hmm.
Not looking so nice. X minus 1 whole square. The other one, it cuts where?
0,
Yes?
2. X plus 2.
So it becomes plus there.
X plus 2.
Now we're going to substitute the values of x and y. It's very important that y is 54 equals to a. Then you have 4 minus 1 squared. 4 plus 2.
Plus 2.
Now 4 minus 1 is 3.
3 square.
And 3 squared is 9.
9
Actually, let me just do this. A, that's 9.
9.
I hope that 9 is 8 doesn't look exactly the same.
6.
And that is 6, which is. Now 9 times 6 is 50. Hello, I'll wait.
Which is what?
Our a equals to 1. So, our equation is y equals 1, which you don't have to write, x minus 1, and x plus 2.
You don't have to write it. Don't need to write it.
Yeah, but I'm writing it just in case. You know, there are special circumstances where special things tend to happen.
Yes.
Yeah.
We both.
So by the way, what type of, if you want to sketch it, will it be like this type, which I can call my A, or this type?
The first one.
The first one, right?
Yes.
And then you see that it will touch, it touches where? At 1. Is it not so?
Positive.
Yeah, so it will be something like that. So I can still ask you technically to sketch, but the problem will be your turning. Now turn all the way up there. You understand what I mean? That is, you don't know how high up from here, so, but it's fine as long as you can indicate the point. And this other point is very important. Let me ask this way. Why is this point not the y? Why is this point not the y-intercept? It is a strange question. Why is the point 4,54 not the y-intercept? Yeah, I know it's not. I'm asking why. No, let's forget about saying passes through. Why is it not the y-intercept?
Because the coordinates.
What about the coordinate? Yeah, what should the x coordinate be in order for this to have been a y? This should have been 0. You understand? So you can't go, when you sketch this, go right here, no, that's the point. You know, what I'm saying? You follow? Because x will have to be 0.
0.
So when you use this, you must read the instructions carefully. This one was saying this function passes through this point, somewhere in this quadrant. It passes. That is the point that is on this function. You understand? Once you draw it, it passes through that point. It didn't say that it is the y-intercept, but irrespective of that, it doesn't matter. Because if you are given the y-intercept, that is also an additional point, which you can use for the values of x and y. You see. Alright? But it should be a point that passes through, or the function passes through that point, or it should be where this graph passes at the y-intercept. Which is this value of d, right, of the standard form. One more before I continue. You have a question?
Anyway, is the origin.
Nah, but check, it does not pass through the origin here.
But I'm just saying.
Yeah, but you know what? Passing through your 0 here, 0 here, 0 here, it's okay, a will definitely equal to 0. Now, we also know that A cannot equal to 0. However, if that is 0, that is 0, that is 0, you can get some value. You agree with me? Multiply it with some A, but this side is 0. What does it imply? Can you see that?
Yeah.
So the instance where you have that is when you have that inflection that I was talking about. And that, who can tell me what type of graph will be? Where it passes, as you are saying, through the origin, but it's not really, it has an inflection point. What type of graph will it be? Okay, I told you the other one. Remember type 4? I was saying P of x equals to x minus alpha all cubed. Then you still have that times that times that. So where will it pass through the origin? If x is 0, what is 1? I'll repeat. If x is 0, what is y? What is 0 cubed?
Zero?
No! Listen, when you are in ordinary level, you have a table of values, right? You have a table of values, x here, y here. Remember this, right? Maybe you start with -2, -1, could be 1, 0, 1. You understand what I'm saying? Then you find, that's your domain. So you find, what did I say? Is this? -1, that must be 0. Maybe that's 1, that's 2. Right. I was asking you, if x is 0, what is y? This is not a discontinuous function. The denominator, there's no denominator with x here. So the value exists. 0 raised to the power of 3 is equal to. Yeah, you're not very confident. Like, create my calculator just to make sure. Now I'm gonna ask you a question because you guys are undecided. It's very weird. 0 raised to the power of 0 is equal to. There you go. Anything? Go on. Repeat that sentence. Anything raised to the power of 0, it does not exist. What are you saying? Okay, but 0 raised to the power of 3.
Zero.
So what is 0 times 0 times 0? Yeah. When I say 0 raised to that, that's 0 times 0 times 0. Good. If you plot this graph, is this graph not going to pass through the origin? But you understand what I mean? It doesn't go straight. It nearly goes straight. That's why we say there's a point of inflection. So if x is -1, you cube, you get -1. If x is -2, you get -8.
I see.
I don't know if you can see the behavior. You are now somewhere x is -1, then y is -8. All the way down here. Can you see that? It comes, so it's nearly like a straight line, but it has a curvature. It does turn. But it's not obvious for you to see the turning, the maximum or the local maximum and the local minimum. So it has like, that's why I said it's like that warm type thing. Can you see that? That point is the point of inflection. So the point of inflection here for this function is going to be at the origin. You understand? So if you were to sketch that, it's going to be obviously something that starts from somewhere, but it has a sort of a turn and goes. Okay? It's a little bit not as perfect as is, but you get the point. Okay. When it's 1, when it's 1. When it's 2, it's 8. Can you see? 8 is small increments of x, very big increments of y. Because you are cubing. You follow? X is 2, then you get to 8. X is 3, you get to 27. Can you see that spike there? Right? That is basically how that function will be. So that's why I gave you the 4 types so that you can be able to remember. Remember that when it comes to differentiation. When you are going to be asked now, let me sketch the cubic function, given information. Now to find the turning points, the local maximum and the local minimum, you will have to find the derivative of the function. And we'll talk about that when we get to that. Okay. The last one, or can you continue? I want to start with chapter 2. If you look at B, page 35, you have got the equation of the cubic function, where the graph touches the x-axis at negative. So it will x plus 2 over 3 all squared cuts the x-axis at 4. X minus 4. Are you with me? And then you have got another point. So these two questions are very similar. No? Then you just substitute x, which is negative 1, and y, which is negative 5. There. Are we good so far? Are we on point? Good. Now, anything that you claim as you are sitting there, Mr. Max did not discuss with you, you are looking for trouble. Okay? That is the end of chapter 1. We have had a roller coaster ride, people. As I said, we are going to, in our workshop that we're going to start, holidays, 2 weeks long, by the way. So you need to already start giving sort of hints, leave breadcrumbs for your parents, because the idea, there is a winter school that we are thinking of. Now, if we have a winter school, then it's not even going to be enough time, because we have to finish the 5 topics. So that in term 2, I test you on theme 1. That means we will be doing, most probably, as we are continuing now, we probably will finish 70% of chapter 2. Okay? And then we need to go on maybe the winter school that week. That means school closes a week earlier. That week earlier, we can have our sessions here, but you have accounting class and stuff like that. We'll finish. It will only be enough there to finish chapter 2. Chapter 3, all that, chapter 4, chapter 5, chapter 6, chapter 7, is what we need to finish over a 2-week period. From 8 o'clock till 5 o'clock. But we will play around with the time, especially Fridays. Okay?
We need to chill for a bit.
It's
No.
like in the school.
Clearly, you don't know how my workshops work. When I say on Fridays, probably I'm referring to, I might say, okay, let's work until 3 or until 1. Then obviously you have to work over the weekend and so on. And Sundays I come, I test you, all right? To recap on what we have covered. But we need to finish that. Because come second term, we start with theme 2. Further integration, further differentiation.
Sunday's holiday. We're going to start.
Yeah, you'll get it as soon as I have a few dates out of the way. I'll give you that. Can we see? I'm starting with chapter 2. Most of the stuff is revision, so I'm going to do selective questions up until the point. Okay? So please don't just sit like that guy now is sitting, thinking this is a Bible study group. You are just sitting there listening. You need to take notes, sketches, all the stuff. Although you might get that stuff, I know you're not going to go through that. Okay. Where is the white paper that I gave you? You see, you sit here because you are poor. You don't have it. Poverty. You had a whole rum. Oh, that was mine. It wasn't yours.
Yes.
Hello, I'm not sharing. I'm tired. But for now, maybe just take 10. Now you see, she also wants. No, let me be the one.
I had for us.
Oh, you see, this guy, did you even cover your file? Where's your file? It's not about being rich. When I was saying poverty, I was referring to poverty of mind. Your mind, you're poor in your mind. Poverty is a mindset. Oh, I'll edit that part out. I'll have to download. You know what? Maybe we should just upload that one just as easy and see what the reaction will be. Okay? This is what Mr. Metz does in his class. Unbelievable. Actually, that's what he did. Maybe when you do find some few dollars here and there, invest just a little bit. I mean, I already did so much for you. I gave you a free file, free education, free food. But let me be honest, when we have our workshop in the past, our school used to